Hi everyone, Gavin here. Today we're going to be looking at the force between two charged particles on either end of a right triangle. So you can see I've already drawn it out here. We have charge 1, charge 2, separated by a distance r at an angle theta. This is a very general problem, very straightforward introductory physics problem. So, first thing we need to remember is Coulomb's law. So F equals K Q1 Q2 over R squared R hat. Now, a lot of times introductory students tend to leave these off, and that's all right, as long as you're aware that they're there. They need to be there in some cases. So one of the ways you can solve this problem is by changing r hat and r vector into their x and y coordinates, and then you can solve this and get the x hat and y hat components. However, I think I have a much better way to do this. So we can draw a similar triangle here as you've probably used to. Is we can go f total is here, fy is here, fx is here, this angle here is theta. So we know from our earlier physics classes, if you've taken them, that cosine of alpha equals we're working with theta, aren't we? Theta is equal to fx over f total, which gives us f total equals, fx equals f total cosine of theta, and similarly sine of theta equals fy over f total. That leads to fy equals f total sine of theta. So we've got these two equations. These are going to make our lives way easier, because while I should have written it more explicitly, these are really magnitudes here. And so now we don't have to deal with this r hat problem that I mentioned before. So we can just find f total, and that's very straightforward. So k is just 1 over 4 pi epsilon naught. That's just a constant, so we don't need to worry about that right now. Q1 Q2 over r squared. So that's our f total. That was very straightforward. All we had to do was remove the r hat. Now, if we need to know f in terms of x and y hat components, we can say f equals k q1 q2 over r squared cosine of theta x hat plus k q1 q2 over r squared sine of theta y hat, and box that in too. And now we found our solution. So that was very straightforward. So this works for any angle theta. You will, as you go above 90 degrees, come into issues where your calculator isn't going to be able to find theta because it will exist in a region that doesn't work. But all you need to do is move that into the first quadrant, and you'll be fine. And I think that's about everything. So if you have any questions, comments, concerns, feel free to leave them in the comments below. And if this was helpful to you, share it with your classmates. Thanks. Bye.